Namaskar. Very warm welcome to all the viewers and learners in this live interaction of CIT NCERT. I am Renu Bhatt with you all and you are watching us live on PME Vidya channel, channel number 10. And apart from this channel, you are with us on our YouTube channels as well, that is NCERT Official and NCERT PME Vidya class number 10. And dear viewers, as you can see, I am accompanied by our sign language interpreter. Let's meet her. You are Ms. Sonal Sidhu. Sonal, very warm welcome. And dear viewers, this session is for mathematics 10th standard students and the topic that we are going to discuss today in this specific session is surface areas and volumes part 2nd. We have already discussed about part 1st. If you want to see or watch that video, you need to explore our YouTube channels. And dear viewers, as this is our part 2nd, we have joined by our expert to throw more light on this particular topic. So without any further delay, let's quickly meet her. You are Ms. Lata Sharma. You are President Awardee teacher from Mother Mary School, Delhi. Very warm welcome, ma'am. स्वागत है आपका.
Thank you, Renu ji. Hello, viewers.
And before we begin this particular session, let me share a very important piece of information with you all in case you want to be a part of this particular live interaction with all your queries and doubts. You can reach out to us through our various mediums. We want you to call us on our telephone number, that is 8800 440 Either you can drop a mail as well with all your feedbacks. Our email address is dts.class10@cit.nic.in. And if you have joined us through our live streaming, then you have to go to the live chat box and then only you can drop your comment out there. Our expert will be more than happy to answer all your queries and doubts if you have any. So let's quickly start this particular session where we are going to learn more about surface areas and volumes part 2nd. So ma'am, we are in the part 2nd, right? So
yes.
Could you please recapitulate the first session, ma'am?
Sure, Renu. In the previous session, children had learnt about how to calculate the surface areas of combination of solids.
Okay.
They had 3D objects, and when we were combining the cube and cuboid, cylinder and a hemisphere, we learnt how to calculate the surface areas.
Okay.
Today we are going to learn how to calculate the volumes of the 3D objects when they are combined. Okay. So let's go through the learning outcomes for the session.
Sure,
Learners will be able to calculate volumes of combined solids formed by joining basic 3D shapes like cubes, cuboids, cylinders, cones, spheres, hemispheres, and they will be also able to solve real life problems involving volumes of combined solids. Okay.
So that will be interesting, ma'am.
Yes.
Shall we start the session?
Yes. Let me show you, children, how we have different types of combinations of solids here. You can see on your screen that we have a hemisphere and a cone attached.
Okay.
Right? Then, Renu, we have a cylinder with two cones attached. Right?
Yes, ma'am.
And in this, you can guess we have a cylinder with two hemispherical ends. Okay. So we will have to learn how to calculate their volumes. Okay. Here we can see cylinder and a hemisphere. In this we have cuboid and a sphere. Okay. So children have a good idea how they can calculate the volumes. We have a cylinder, cube and a hemisphere. Their volumes have to be taken out with their formula and they can be added to calculate the total volume of the solid.
Okay.
Okay. So here we begin with the question. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter and the height of the cone is equal to its radius. Okay, read the question very carefully, children. We have radius equal to the height of the cone. Find the volume of the solid in terms of pi. Okay. So here as we can see, Renuji, we have a solid which is a combination of a cone and a hemisphere. Okay. Radius of cone is equal to radius of the hemisphere, that is 1 centimeter, and it is also given that height of the cone h is equal to 1 centimeter. So what is the volume of solid? It is volume of cone plus volume of the hemisphere. I can show you the model, children, here. Can you see? This is the hemisphere.
Right.
Okay. And this is the cone which is attached to its surface. Okay, I think this makes it more visible.
Yes, ma'am.
Okay. So we will be calculating the volume of this solid.
Okay.
Alright. So let us solve it here. As we know, we are given the height and the radius both are equal to 1 centimeter. this is 1 centimeter, this is also 1 centimeter Renuji, and this is hemisphere and this is cone. Okay. So, what is the formula for calculating the volume of a hemisphere? As children have learnt it, it is 2 upon 3 pi r cube. Okay. And what is the formula for calculating the volume of a cone? It is 1 upon 3 pi r square h. Right, children? These concepts are very important, children, and in board exam we get these questions, you know, Renuji, and I am going to teach them a simplified way of solving such questions.
Okay.
They should not be scared of this. It is very, very easy. Sometimes children have a fear that it involves so much of calculation and they will not be able to do so. It is not that the case. They have to understand the question, read it, and then visualize what is the object formed here. Okay. So, here we have two objects, we know their formula. Now, we will be taking common. Look, what is common here? I know radius and height both are 1 centimeter. Can you see here? And then pi r square happens to be common in both the formulae. So, let me take pi r square common. Okay. Now, let us see what is left out. We have 2 upon 3 and 1 r is left out, Renuji, because r square I have taken out, only 1 r will remain inside, plus 1 upon 3, and here pi r square is outside. So, only h is left now. I hope it is clear. Now, we will substitute the value of r and h. Both are 1 centimeters. So, let me write down the values and calculate. Pi into 1 square and within brackets 2 upon 3 multiplied by 1 plus 1 upon 3 multiplied by 1 again, because the value of height is also 1 centimeters and the volume is going to be in cubic centimeters, or we call centimeter cube. Now, let us solve this. We have pi, because I am supposed to give the answer in terms of pi, Renuji. So, I will not put the value of pi, I will just write down pi and solve this. What is 2 plus 1? It is 3, and LCM is also 3, because 3 is there in both the terms. So, what do I get here? I get 3 upon 3, which is obviously 1. So, my answer is pi centimeter cube. So, the volume of the solid will be pi centimeter cube. I hope it is clear, children.
Very much clear, ma'am.
Okay. Now, let us look into another question which is very interesting. Rachel, an engineering student, were asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 centimeters and its length is 12 centimeters. If each cone has a height of 2 centimeters, then find the volume of air contained in the model that Rachel made. Okay. Question appears to be little big, but children should not be scared of it. They should visualize the problem. Okay. First, you try to understand the model. Here the model is a combination of cylinder and two cones, children, right. So, volume of the air will be equal to sum of the volumes of the two cones and a cylinder. Simple. Let me show you the model I have made for you to understand. See here, this is the cylinder,
Right.
and these are the two cones. Okay, children, and the total height is given, total length is given. How much it is? 12 centimeters.
Okay.
And Renuji, it is mentioned that the height of the two cones is 2 centimeters each. So, this is 2 centimeters, here also 2 centimeters, it becomes 4 centimeters, and children, if I subtract 4 from 12, I get 8 centimeters, which is the height of the cylindrical portion. So, the height of the conical portion is 2 centimeters this side and 2 centimeters on the other side also. Agreed? Okay.
Yes,
now, to calculate volume of the air inside the model, children, I need to calculate the volume of the air inside the cone and cylinder and the other cone, right? Cone, cylinder and cone, and you will be noticing that these two cones are similar, right? So, I can write down 2 times the volume of cone plus volume of cylinder. Yes?
Yes.
Okay. Now, what is the volume of cone we had used in the previous question? it is 2 times, we have volume of cone as 1 upon 3 pi r square h1. I have taken height as h1 for the conical portion, okay, plus what is the volume of cylinder? Pi r square h2. We have taken this height as h2, which is 8 centimeters. I hope I am clear?
Yes, ma'am.
Okay. Now let me calculate. Here what do I notice? As I told you, if you take out common, it becomes easy for us to calculate. So if I write down pi r square outside the brackets, look what is left inside. I am having 2 upon 3 into h1, agreed? Okay, plus here pi r square is outside. So what is left? Only h2. Okay. Now what is the value of pi, children? We can use 22 upon 7 as it is not mentioned. Remember, if it is mentioned in the question, you have to use 3.14, always use 3.14. And if it is not mentioned, for such questions, we should always put the value as 22 upon 7 for pi. Okay. So into, what is the radius here? It is 3 upon 2 into 3 upon 2. Agreed? Because here we have taken the radius as 3 upon 2, diameter was 3, and this becomes 2 upon 3. h1 is the height of the conical portion, that is 2, plus what is the height of the cylinder? It is 8. That is all. I need to calculate this. So here 2 1s are and 2 11s are, and here you see 2 2s are 4 upon 3 inside the brackets plus 8, and I have 11 into 3 3s are 9 divided by 7 2s are 14. Okay. Now I get 11 into 9 is 99 upon 7 into 2 is 14. Here we have 4 plus what is 8 3s are, children? 24. What is 24 plus 4? It gives me 28. So it becomes very easy for me to compute. I get here 99 upon 14 into 28 upon 3. 3 1s are and 3, 33 times is 99 and 14 2 times is 28. So what is the answer left with me? It is 33 into 2, that is 66 centimeter cube. I need to mention the units, it is mandatory, remember. Okay, volume is always measured in cubic units, children. If it is given in centimeters, we write centimeter cube. If it is given, measurements are given in meter, we write meter cube. I hope it is clear?
Yes, ma'am.
Okay. Now let us look into another question. We have a solid is in the form of a cylinder with hemispherical ends, Renuji. The total height of the solid is 20 centimeters and the diameter of the cylinder is 7 centimeters. Find the total volume of the solid. Here we are supposed to use pi is equal to 22 upon 7. Let me show you the model, children. Here we have this as the cylindrical portion and these are the two hemispherical ends, children. Can you see this? Okay. I have taken a ball, cut into 2 parts and I have attached across the cylinder. Alright. So we have a cylinder and 2 hemispheres. If I have to calculate the volume, what I should do? I should take out the volume of cylinder and add volumes of 2 hemispheres. If I add these, I will get the total volume of the solid, right? So let us do it. We have height of the cylinder is how much? It is given to me as 20 centimeters, okay? And 3.5 and 3.5 were the corresponding radii of hemispherical ends. So if I add 3.5 and 3.5, I get 7 centimeters. So on subtracting 7 from 20, I get 13 centimeters as the height of the cylindrical portion. Okay. Now what is the radius? It is given to me as diameter is 7. So radius will be obviously half, 7 upon 2 centimeters. So volume of solid is obtained by adding volume of cylinder and volume of hemisphere. Okay, we have 2 hemispheres, so I will write down 2 into volume of hemispheres. Now what is the formula for calculating the volume of cylinder, children? Yes, you are right, pi r square h plus, as we are having 2 hemispheres, children, we will write down 2 into 2 upon 3 pi r cube. Yes? Okay. Now again, let us take out common. Can you see the radius is same, children? That is the benefit we have. So, we can take out common, we will have pi r square, and what is left here? Height h plus 2 into 2 gives me 4 upon 3 into r, because r square is already outside, only one r is here. So, we will have this calculation to be performed. What is the value of pi? 22 upon 7. What is r? It is 7 upon 2 whole square. And what is the height here? Height of cylinder is 13 plus 4 upon 3 into 7 upon 2. 2 ones are and 2 twos are. Okay. This on calculation will give me how much? See, 22 into 7 into 7 upon 7 into 2 into 2, because it is square. So, here what I am left with? 13 plus 7 twos are 14 upon 3. Okay. If we calculate this, children, 7 gets cancelled, 2 ones are, 2 11s are. So, 11 into 7 is 77 upon 2 is the value outside the bracket, and look inside, 13 threes are 39 plus 14 divided by 3. This gives me the volume. On computation, we find that 77 into 53 upon 3 twos are 6 in denominator. What do I get? It is 680.17 centimeter cube. Okay. This is the volume of the solid. Alright, I hope it is clear.
Yes, ma'am.
Then we have an interesting question here. A pen stand made up of wood is in the form of a cuboid with 4 conical depressions to hold pens. The dimensions of the cuboid are 15 centimeters, 10 centimeters and 3.5 centimeters. This is a question from your textbook. The radius of each of the depressions is 0.5 centimeters and the depth is 1.4 centimeters. Find the volume of the wood in the entire stand. Calculations are pretty simple. Just understand the logic behind why we are subtracting the volume of the conical portions here. Length of cuboid, as you know, the formula is length into breadth into height. We have calculated the volume of the cuboid, and then we are removing the wood which is conical in shape. Okay, so what is the volume of a cone? 1 upon 3 pi r square h. We have multiplied it 4 times and we have subtracted from the total wood. So, you can see here 525 is the volume of the cuboid, and volume of 4 conical depressions, children, it is 22 upon 15 centimeter cube. On computation, we find that the left out wood in the entire stand will be 523.53 centimeter cube. Okay. Here comes another interesting question, children, and it is very important also. A vessel is in the form of an inverted cone. Its height is 8 centimeters and the radius of its top, which is open, is 5 centimeters. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeters, are dropped into the vessel, 1/4 of the water flows out. Okay. You need to understand the concept here. Find the number of lead shots dropped in the vessel. First thing you must see that we have only 2 shapes involved here. What are they? Cone and spherical lead shot. So, I must know formulae of cone and formulae of spherical lead shot to calculate the volumes, obviously. Now, since lead shots are dropped into the vessel, so the water which flows out from the vessel is equal to the volume of the lead shots. So, height of the vessel is 8 centimeters and radius of the vessel is 5 centimeters. Now, to calculate this, let us do the computations here. N into volume of one spherical lead shot is equal to 1/4 of the volume of the water in the vessel. So, here it is very easy, Renuji, because N into what is the volume of one spherical lead shot, children? 4 upon 3 pi r cube, that is equal to 1/4 of 1 upon 3 pi r square h, because volume of the vessel is what? It is conical in shape. So, 1/3 pi r square h is the volume of a cone. So, pi gets cancelled on both the sides, 3 in the denominator also we can cancel out, and we have n into what is the value here? 4 into what is the radius of the spherical lead shot? 0.5 into 0.5 into 0.5, that is equal to 1/4 of, what is the radius of the cone? It is 5. So, 5 into 5 into 8, 4 ones are 4 twos are. So, as you can see, n is nothing but I have here 5 into 5 into 2 in the numerator.
Ji.
Okay. And what is in the denominator, children? It is 4 into 0.5 into 0.5 into 0.5. If I remove the decimals, Renuji, it becomes very easy. 5 into 5 into 2 multiplied by 1000, because 0.5, 0.5, 0.5. So, 10 into 10 into 10, I get 1000 in numerator, upon 4 into 5 into 5 into 5. Look here, we can cancel out these 5s. 2 ones are, 2 twos are, 2 5s are 10. 10 I can cancel out with 1 10 here in 1000. So, number of lead shots will be 100. Alright.
All right,
so, it is easy for you to calculate. I hope you will be able to perform the questions in the exams.
I'm quite sure they will, ma'am.
Yes.
Definitely. Or it's time for us to wrap up this session here only, because we are running very short of time. But before that, let me thank our expert. Thank you so very much, Swanata ma'am, for being here. Thank you, ma'am.
Thank you.
For this wonderful explanation. And thank you so very much, Sonal, as well. And dear viewers, let me share a very important piece of information with you all. In case you want to order NCERT's new textbooks for class 4 and 7th, you can order it from Amazon, Flipkart, and from NCERT official website as well. And let me share other programs as well. In a short while, we will be back with our another live interaction, that is our online training program. At 4, and at 5 p.m. we will be back with our another live interaction, that is Sahyog, and the topic that we are going to discuss today in that particular session is creative breakthrough for self-expression. At 5:30 NEPA will be there, and we want you to participate in all these sessions with all your queries and doubts. Me, Renu Bhatt, is taking your leave, but you stay tuned to PME with their channels for more informative programs. Namaskar.